Hey guys, welcome back to math class. Well, sort of. Okay, so let's run through these practice problems for the worksheet 13-3 on experimental probability. All right, so the first one says we've got a spinner, all right, and we've got 3 colors for this spinner. All right, so we've got three sections. We'll pretend they're all the same. All right, so we've got one green, all right, and the table says based on the table, we hit the green 8 times and hit the blue 7 times and we hit the red 5 times. So there's the data that was collected over the total spins. All right, so we've got a total spin of 20 spins. All right, so finding the probability says what's the probability of the spinner landing on blue. All right, so we need to first figure out how many times did it land on blue. All right, that's our frequency that goes on top. And according to this, it landed on blue 7 times. All right, the bottom number, remember, is how many trials there were. So in other words, how many times did we spin? We add all the trials up together and we get a total of 20. So your probability of it landing on blue based on this table is 7/20. All right, or you could have simplified that to 0.35, all right, which is about 35%. All right, but your answer should be in either fraction form or decimal form. All right, these next 2 problems were based on this table here. All right, so we've got a basketball player shooting, all right, 100 times. All right, so the left column is showing you the attempts broken up in 25 shot intervals. All right, so during that first 25 shots, he made 17 of them. All right, taking the next 25 shots, he made 21. Next 25, he only made 19, and then the last 25, he made 16. All right, so the first question simply says, what's the probability that the shooter makes their next shot? So overall, for the total, based on this data, they took 100 shots. All right, so the probability of them making the next shot, the frequency of them making it, we're gonna add all those together, all right? So total made is 73. So that's our frequency. And total shots is how many trials? And that's 100. All right, so can't really simplify that, so you can either put your answer in 73/100 form, or you can put it in decimal form, which is 0.73. Okay. Now the next question, all right, is a little bit more complicated. It says, what's the experimental probability if of the shooter missing a shot during the last 25 attempts? All right, so that during the last 25 attempts, we only want to focus on the last 25. All right, and that particular data. Okay, so we only want to focus on that portion of the data. So the last 25 attempts, all right, trials is now 25, because we're not talking about the total thing. We only want to focus on these 25 shots. So that's the new denominator. So I've got 25 total trials. Out of those trials, how many did they make? Well, they made 16, right? So that's how many they made, all right? Now I want to say, okay, well then how many did they miss? All right, well if I just subtract that from 1, then that'll tell me how many they missed. So in this case, they missed 9 out of 25, okay? So that is your experimental probability on how many they missed, right? So you can do 9 out of 25, all right? Or put that into decimal form, and you end up with 0.36. So number 4 is pretty straightforward. They give you a table showing how many days that the temperature was above 90 degrees during specific months, all right? So the question is asking, on any given day in April, all right, so we only want to focus on April, all right, what's the probability of having a temperature over 90 degrees? Well, according to this, it says there were 5 days over 90 degrees, all right, in April. All right, and then so that's going to be our frequency. All right, so 5 days. And then our total trials, well, how many days are in April? Well, there's 30 days. Hopefully we know that. All right, so your final answer in reduced form, all right, always simplify your fractions, is going to be 1/6. All right, if you wanted to put it in decimal form, I would have taken 0.16 or 0.17 if you rounded it properly. All right, so either one was an acceptable answer for number 4. All right, last but not least, we've got a standard deck of cards. All right, so hopefully we remember that they're the same amount of each suit. All right, there's 13 hearts in a deck, there's 13 spades, 13 clubs, and 13 diamonds. All right, so those are all equally likely of coming up. All right, so it says after 100, all right, after 100 trials, 32 times, all right, we pulled a heart. All right, so based on the data collected, that would be the probability of drawing a heart. But we want to know what's the probability, experimental probability of not getting a heart. So again, we want to subtract that from 1, all right, because we don't want a heart. And that's going to give us a probability of 68 over 100. All right, if we simplify that, then that simplifies to 17 over 25. So that would be your acceptable answer, or we could put it in decimal form and do 0.68. All right, so there's approximately a 68% chance based on that data that we draw a card that is not a heart. Okay. Don't forget to go back through and enter in all the correct answers and resubmit if you didn't already, so that way you get full credit for the assignment.